Hello guys. Good evening. Welcome to the Henry Holster Shop. 10 viewers already. That was fast. You guys are on the ball. Hello, Richard Perry. I taped up the connection on my microphone extension cord, so I'm really hoping that prevents some of the wobbling and popping and other problems we had in previous broadcasts. We'll see. So, I got a tool tip about this pump to start, and then we'll get into the topic of, hey, PJ, Go Hard Holsters. I did not get the AR Magazine carriers up on the website yet. It's been a busy day, and sometimes I just don't get to everything. Hey, Brandon. Hello, Ben Miller. Hi, Mark Lancaster. You are squared away. Tom Kelly and other guys shared it. Awesome. If you're here and you're a holster maker, as usual, please post up your company name in the comments. I would very much appreciate it if you would share the feed. Guys, you did an awesome job. Last time, episode 22 had over 33,000 views, which totally blew away anything I've done on live video before. And it was, entirely because of the guys who shared it and invited people. So thank you very much. I was totally psyched. Hoplite Holsters is here. Hostetter's in the house. Hello, Dean Kennedy. I don't have a mold giveaway tonight. I'm kind of out of swag at the moment. This is the post-holiday doldrums. Hi, Jess Hazelar and Matt Bills. But I would still really appreciate it if you would share the feed. It gives me a chance to talk to other people in the holster community and in your circle who may not know about my work, and it's a boost to me and my business to be able to speak to them and share the information that I have to give, which I hope is valuable. I try to make it as valuable as I can, so I'd appreciate that. Scissortail Custom is here, won't be here for long. Will Silk, Baton Rouge, Louisiana. So, I got a new Robinair 15800 today. I already have one, but I wanted a second one for two reasons. The first one is I'm a big believer in having a backup of equipment that is vital to the process in the shop. So I've got two band saws, I got 3 drill presses, I've got a couple Swift presses. I only have one big CNC mill. I could only afford one. But I have now 1, 2, 3, 4. This is my 5th vacuum pump in the shop. And so in an emergency, even if 1 or 2 of my pumps went down, I would have the ability to replumb some things and get back up and running without having to wait to see who had a pump in stock and who could ship it to me. But the other reason is I wanted to be able to do demonstrations away from my usual forming area over here at my work table and not have to always go and disconnect the pump that's plugged into my Swift press, but just have this one available kind of as a free pump that I can move around to wherever I need to for the video. But I know I've commented on this in some threads on Kydex Places before. When the pump comes, it comes with these little black plastic caps and these brass fittings on the pump. And you want to get rid of these. These are flare fittings. These pumps are primarily designed for HVAC work, working on home air conditioning systems and things where a tech is using this pump to pull a whole bunch of contaminated coolant out of a system, which is also why the oil change recommendations in the user manual are like, change it frequently if it gets cloudy, if you see debris in it. If you're just using this to vacuum air in a vacuum press, I go usually 12 to 18 months between oil changes easily. And if you put an oil mist eliminator on here, which actually traps and then recycles the oil back into the pump, then the number of times you'll have to top off the oil will also be lower. So we're repurposing this pump for what it was not initially designed for and what it's not primarily marketed for. So the fittings that come on here are designed to allow HVAC guys to plug into refrigerant systems and draw refrigerant out. We don't need that. And the inside diameter on these holes is small. I've seen some weird hodgepodge things. I've seen guys use flare fittings, like natural gas propane fittings they would use to hook up, a gas stove or a gas dryer, and putting it onto here, or taking this and putting an adapter and then a bushing and then a hose barb, and you end up with just this, this mess of adapters and stuff. Hey, Greg Thompson. Oil mist is slowly killing me, says PJ. I am working on a solution for that. That's the other reason I wanted this pump. So far, I've not filled this up with oil. I've already taken this off and poked around inside it. I'm going to be seeing if there's any better way to adapt the oil mist eliminator system that I use onto these Robinair pumps, because this output tube on this pump is not the standard fitting that most vacuum pumps use. This is a very budget import line pump. Robinair brands it, it's made overseas. Robinair doesn't really offer parts or service or support on it. And so it's not really built to industry standard. There are a number of other brands of higher end vacuum pumps that have more standardized fittings so that accessories and connections and things are cross compatible. Not the case with the Vacuum Master line from Robinair. But I still think this is the best value for the money for a small holster shop. These things are awesome. Mine has been a tank for years. So I'm working on buying a batch of 40 or 50 of the oil mist eliminators from Minnesota Vac that I use on my pump, but we have to get a non-standard adapter fitting made and an extra clamp and some other things. And so I've been talking with Bill Meredith from Minnesota Vac. Things are moving a little slow because it's the holidays and he's not been in the shop all the time and I've been out of the shop a little bit. So you'll hear more about that from me. I'll be posting about it on Instagram and probably on the Kydex Facebook groups in the next week or two. Hello, Gary Gonzalez. So if you're interested, if you have one of these pumps and you're having an issue with oil mist, just a general thing about when the pump will actually aspirate oil. If the pump is drawing against a tight system with very, very few leaks, once you get up to pressure or down to pressure to full vacuum in that system, and there's not really any free volume of air moving through the system, very little volume of exhaust is actually coming out of here. Where you'll typically see, more mist is when you're drawing on an open line or when you're pre-vacuuming a surge tank, or if you have a leaky system and even when you're up to vacuum and you've got your press fully sealed, the pump is still pulling some volume of air. So one of the things I would suggest is if you're seeing more mist than you think you should, do a little smoke test around your press and see whether or not you've actually got some leaks. And if you do, patching them will only mean you get more performance out of your vacuum system and would be worth your time. I always see a little bit of visible mist when I'm running my Swift press before I lay my plastic down and the vacuum pump is just drawing on an open port under my mold. There's no seal formed. Hello, Seth from Adrian Consuming in Frederick, Colorado. Thank you for stopping in. Hi, Nick from Blade Rigs. You said this was like Nerd Geek TV for Kydex stuff. And I resemble that remark, Nick. I appreciate that. Nerds, no nerds, no nerds. And so the only time I really see any mist out of here is when I'm vacuuming on an open table, an open port. Once I've got my seal formed, I'm really not seeing much mist at all. But if you are seeing mist in your system, I want to try to find a way to provide a mist eliminator that works for you. Now, the one that I use from Minnesota Vac, depending on what you read about it and when you talk to Bill Meredith, this pump at 8 CFM is at the very upper limit of what that oil mist eliminator can handle. So if your pump's putting out a ton of mist, that oil mist eliminator is not going to kill 100% of it. It should significantly reduce it, and it will slow the rate at which your pump loses oil. But it's probably not going to turn your shop into a sterile environment that's completely oil-free. It does pretty well in my shop. The other option, which you just may seriously consider, is get some oversized hose and a spring clamp, and cinch a hose on here. Keep this as close to an outside wall as you can, and actually just pipe the oil mist outside your building. Depending on where you are and what you're near, that may or may not be a good option for you. If you're working in your garage and you'd be venting it out onto your back deck, probably not a great idea. It might make a mess. But if you have the option, venting it outside may be worthwhile for you. Just a thought, if it's really bugging you. When the first month that I had this pump and was vacuum forming here in the shop, it was December. It was really cold. I did not have a mist filter. My system was leaky. And I also tried using it for vacuum clamping on my CNC. I was moving it back and forth from my CNC to my vacuum press to my CNC. And so one day I was CNC trimming parts, and I basically ran the pump for 12 hours straight with just very brief shut-off periods to change out the parts on the machine and then run the pump again. and like the top 8 feet of the shop were just filled with smoke. It was 20 degrees outside. I had windows open at both ends of the shop. I had box fans in the windows and was drawing in air at one end and blowing air out at the other end, trying to get the oil mist out. And then I eventually just opened the garage door at the front of the shop. I was freezing, but there was so much mist I had to do something. Hello, Joseph Hazelar. Thank you for being here. And so more's coming on the oil mist eliminators for these. If you have one and you've still left these brass fittings in place, what I recommend is get a crescent wrench, get right on here, back turn this entire brass assembly out, thread it out of the block. You can put in a straight 1/2-inch NPT to push to connect fitting. I buy these from MSC Direct. This is the Jupiter Pneumatics brand, very inexpensive, but I always drill out this flange right here on the inside because it comes tight. Doesn't need to be. I just take a drill bit and drill it out and get a little bit more flow through there. Or you can use, for a couple bucks more, a nicer Legrease swivel elbow, which is this fitting I use on the underside of my Swift press and the one I used in the thrift press video. And you could also thread this directly into your pump body, and then all you do to hook up the pump to the press is stick your hose in the pump, stick your hose in the press, done. Sounds like how my garage smelled when laser cutting Kydex. Yeah, ooh, laser cutting Kydex is nasty. So that's it on the Robinair. One other thing I wanted to talk about that was being discussed on the forums this week, and then we'll get into Mike Hallam. You tie directly into this next conversation, and I'm going to criticize you. So glad you made it. Holster Co's in the house for a little smackdown. Well, not really. Sup, dude? Little late, I was building trim molds, says Skylar. Awesome. Well, we won't be building any trim molds, but I'll be discussing them, how I design them, different ways you can build them manually, what to think through, how to use them safely, and then recommendations for router table setup and pre-cutting, all that fun stuff. Hello, Jamie, Titan Concealment. So a couple videos ago, I commented on these. I'd gotten my samples from Keith Freeman at Hazmat Holster Works. And then somebody else put a thread up in one of the Kydex Facebook groups saying, yeah, these are awesome. And a bunch of guys got on and commented that they didn't like them. It doesn't have adjustable ride height, it needs a third hole, various other criticisms of the design of the part. Now, what I want to point out is there are two different factors when we're looking at hardware. There's design and execution. Okay? And what guys were criticizing was design. The execution on these are awesome. They're very clean. The molding is very nice. They're very stiff. They've got good retention. They have adjustable cant. The execution is good. Guys were taking issue with the design. Now, some businesses, there are two very different orientations when it comes to hardware design and production. And what I wanted to point out about these is these were designed primarily, first and foremost, for use on the hazmat holster line. Anytime a company designs proprietary hardware around their product line, it's going to reflect the choices they've made in their product, and it may not reflect the choices you've made for your product. And so it wouldn't be a surprise if somebody else's holster hardware for a very different design than yours didn't also work well for your design. That's like saying, I don't know why these tires off my minivan don't fit really well on my big Chevy truck. Well, they're not the same thing. And so I want to make sure you guys remind yourselves and are able to distinguish between differences of opinion about design and criticisms of execution. I have seen and handled hardware that I thought was designed just fine, but was executed poorly. And that's a deal breaker for me. I won't use hardware that's poorly executed. If it looks bad, if it doesn't work well, I'm not down for it. But I can totally look at hardware that was designed for some other purpose, some other setup, a different configuration of holster than what I make, and look at it and say, given the goals the designer had, they've accomplished them, the design makes sense with those priorities in mind, and they've executed it well. It's good hardware. It might not be hardware for me, and I think it's unlikely that I'm going to use these on my holster line, but, I look at them, and when I've talked to Keith about why he designed them this way, and then look at the execution of them, I'd say 10 out of 10. His design was well thought through for the goals he wanted to accomplish, and they're executed well. So there's a big, I just want to make sure the guys are clear on when I recommend hardware and say these are good, you need to check these out. What I'm not saying is these will certainly work awesomely well for whatever holster design you think to try. For a lot of you guys, these are not a good solution. But that's because you're trying to do something different than what these are designed to do. It's not because these are bad or failing in any way. So that's that. And generally, I'm down on negativity. Bobby Jackson says something went wrong. We're having trouble playing this video. I don't know. I'm not seeing a weak connection thing. Maybe your Florida internet's just jacked up, Bobby. But you made me lose my train of thought. Just opened my package for him, and they are definitely hefty and look great, says Brandon. Yeah, so I can appreciate the quality of these while not necessarily wanting to change my design to work around them. But one thing that I would say to you guys is, as you make the transition to new production processes in your shop, always take every advantage you can. Anytime you've got a big reset, new molds, a new forming process, a new trimming procedure, anytime you're jumping to a new level, take a step back and evaluate your design and then say, given the new capability I'm going to have, are there any features on this that could be executed better that are the way they are now only because of production limitations? A horrible, horrible example of this is those holsters that some of you guys have pointed out. I forget which store is carrying them, but it's basically being marketed as a this fits almost any gun kind of holster. And you look at it and go, is that Kydex or is it injection molded? And then you pick it up and go, it looks like bad Kydex, but it's injection molded. I forget the name of the company. I immediately forgot it because it was a waste of a brain cell. But that product was very clearly designed as a poorly made Kydex holster that was 100% reverse engineered, probably with scanning, and then made into an injection mold that duplicated, yeah, that's the one, Brett Pittman, I'm not even going to say it. That's the one, and it duplicated in the injection molded process all the failures, all the defects, all the weaknesses, all the inconsistencies of the original product. The belt loops were an injection molded copy of a badly handmade Kydex loop. The thing is unforgivable. No, not on your 6. On your 6 has nothing to do with this, Brandon. And it was clearly a case of a person looking at the way things were and deciding to make it way faster, way more efficient, but not taking advantage of any of the design improvements that were available through the new process. People, negativity. Yes, I'm down on negativity. And this is another spot where I'm going to pick up and punch Mike Hallam in the face. I don't have any particular problem with Mike Hallam, but it was just on my mind because I saw some stuff from him this week. So, I know, Mike, that you were having trouble with Braintree through PayPal, with your website, and payments being processed without stuff was jacked up, your money wasn't showing up, it might get refunded, orders were going to be jacked up, and product had already gone out. And I read some of the comments on that thread. There were several of them. And I don't know how else to say it besides I don't think you're helping yourself by complaining loudly publicly about it. I could be wrong. Sometimes I don't vent, really. If I'm having a frustrating time, I don't get on the internet and vent about it. Some people do. That's what they like to do. That's how they feel better. But generally, I don't want to spend any unnecessary energy dwelling on problems. Stuff could go, like last night, I did an Instagram live feed, and I drilled through one of my fixtures that I built for John Hauptman. It was hilarious. Like, I've been running parts on that fixture all day, and I changed nothing. I have no idea what happened, but somehow the vacuum seal broke, and the fixture was like a 1/4 inch too high on the table, and the drill bit came down and caught the fixture, pulled it up, drilled through it, and then was spinning my part around. And it was happening on live video, and all the people on my video were like, what? And I'm like, well, emergency stop, big red button. I could have been upset. Like, I was kind of bummed. It ate up time. I had to do some jerry rigging to get the fixture to work again. And I drilled a hole through it, and it's a vacuum fixture. But when stuff goes wrong, I can either, just keep rolling, or I can get myself wrapped up around the axle about it and actually make myself worse. I'm sure you guys have had this experience where you're making a holster, you're under a deadline, you're short on time, you're hurrying, you decide to cut a corner, the corner cut turns out bad, you screw something up, you didn't anticipate a problem, you make a bad bandsaw cut, you drill a hole in the wrong place, something goes wrong, and every notch higher that you stress yourself up and wind yourself up, the worse the work gets, the further behind you get, the more plastic you waste, the angrier you get, and the whole thing just snowballs out of control. It's bad all the way around. So what I want to push for, I want to push hard for you guys when you're dealing with problems to deal with them by taking a step back from them, working on something else. Like at midnight on a business day, venting is helpful because articulating the problem is part of solving it. John, I would say venting and articulating the problem are different. To me, the difference is a public group or a group of friends that may have experience or advice. And I agree there, Michael Hallam. It would be one thing to, it's one thing to explain a problem and ask for help. Hello, Alan Morrison. I just beat my dog or my wife, says Brett. Yeah. I don't know what to say about that. That's bad. Poor dog, poor wife. It's one thing to explain a problem. I articulate my problems out loud, oftentimes loudly in the shop. But there's a kind of venting that doesn't actually want help and doesn't want solutions and just wants to be angry. That's counterproductive. When I start heading in that direction, I got to rein myself in because it's counterproductive. So, We've already called Animal Protective Services, Brett Pittman. They're tracking you on GPS on your phone. They're going to come rescue your wife and your dog. Okay, I'm back, says Joey Gregory. Your Swift Press ship out? Oh, yeah. It's on the way. And you should have gotten an email from my website. And if you didn't, Joey, then that's a problem that I have to keep dealing with that drives me crazy. So now on to trim molds. So what's the purpose of trim molds? Holster I recommend for bigger guys. Matt, that's a really broad question. It would depend climate, clothing, size of gun, position you prefer for carry, what carry experience you already have, any attachments or accessories that are on your light. There's a whole bunch of stuff. Yeah, Joey, I think your press went... I sent your Swift Press out Tuesday, Joey. So it's definitely on the way. If I need to, I can go back manually and force copy-paste tracking info and send it to you. So you'll get it tonight. So, Matt, it's hard to say. But if you wanted to, shoot me an email with a few more detailed specs. Orders at Henry Holsters is where you can email me about what you're actually wanting to carry, and I will try to give you a little more detailed feedback. So, trim molds. What's the purpose of them? The purpose of trim molds is simply to eliminate inconsistency in the trimming process and give you a repeatable profile to your holster without having to do time-consuming measuring or sanding and then checking. The goal is consistency. The consistency breeds speed, but trim routing is not necessarily faster than simply bandsawing and sanding. It depends how much of an ace you are with a bandsaw and a sander. It also depends on the particular profile and shape of your holster. There are some holster designs that you can cut very, very quickly, almost exactly to your finish line with the bandsaw. There are some other holster shapes that are not as easily bandsaw cut to final shape, and you either have to bandsaw cut them rough and then spend a bunch of time sanding, or you can bandsaw them and trim route to final shape. So the reason I first got into trim routing was because I knew exactly what I wanted the holster profile to be. I was not guessing from holster to holster. I was achieving very consistent results, but I was having to do too much test fitting in comparison, or too much laying a template over and tracing and then cutting and then sanding and then checking and then a little bit of resanding and then checking and then a little final bit of resanding and then checking, confirming, then edge polishing, then assembly. It wasn't as fast as I wanted it to be, and it was an unscalable process. It was a process that I could not simply show somebody else how to do and have them do it. Okay? I can say, here's a holster shell, here's a tracing template, mark these 4 holes, trace the outline, go to a bandsaw, cut just outside this line, and then sand until the line's gone. But even there, and even with a skilled worker who already has the tool chops to make clean bandsaw cuts, to not cut inside the lines, and to sand nice, even, straight edges, I still can't perfectly download from my brain to theirs what I want the finished product to look like. But if I give them a trimming template that a bearing guide on a router bit will actually run against and cut it to exactly the same shape every single time, I don't have to download this. I make the trim template exactly the way I want, and then I can hand it off to somebody and say, here, pre-cut this material away, bolt it down to the trim fixture, trace it around, done. And the shape will be perfectly consistent every time, so long as they correctly mount the part on the trim mold. Need to get in on these ASAP, says Mike Allen. Just ship another one, Joey Gregory. Yeah, right. Well, no, by all means. I would be happy to ship another one tomorrow if you would be happy to buy another one tonight. Coupon code is still good. Presses are still in stock. I could ship you another one tomorrow. And so, where you'll actually make up the speed, do I offer outside the waistband trim molds too? Yes, I do. Yes, Tom Kelly. Tom Kelly ruined, well, somebody helping in Tom Kelly's shop absolutely trashed a trim mold by not understanding how a router table is supposed to work, and put the trim mold with the shell on the router table upside down. So the bearing didn't hit the mold and just cut into the mold and cut into the shell. Coupon code, Brett Pittman. I still have, while this last batch is in stock, I have a $40 off coupon on Swift presses. It's the coupon FAST40. It's good on my website, henryholsters.com, for $40 off on a Swift press with free UPS ground shipping in the lower 48. So if you want a Swift press, I've got a handful left. I'm down to 7 of them. So grab one and use the code and save $40. So obviously, this is not a hands-off, completely mindless process. You're going to have to be careful and safe doing it yourself. And if you have an employee doing it, you're going to have to train them and show them and then monitor them and supervise them, because it's not foolproof. It can be messed up. The more you mess around with the router table, I actually am going to, I don't have a second one yet, but I often have to change bits because I use router tables to trim other things besides holster shells sometimes. And so I often have to switch diameters and switch between top and bottom bearing bits, and I'm always having to reset my heights and make sure everything's good. What I'm going to do is just tool up a second router table station, one for trimming holster shells and then one for everything else general purpose, so that I can set up the holster shell trimming one and then never have to mess around with it. Because probably the most common time you'll have trouble is on the very first holster shell after you change bits or adjust the router table. You might forget to fully tighten the collet and the bit might wander up or down. You might not set the height properly and your bearing may come in under the edge of the trim mold and allow you to cut into the mold. There's a whole bunch of things that can go wrong there. Go slow when you're setting up your router table. Take your trim mold with your router locked out, unplugged so it cannot be switched on, and then eyeball and make sure you've got bearing contact of the full height of the bearing in contact with the trim mold all the way around, no surprises, and only then the trim shell separate from the mold. They have to be different, Tyler Miller. I will explain why. So be careful and consistent in your setup. Take the time to set up slowly, double check. Don't rush setting up a router table, because a router table is an open blade going 15 or 20,000 RPM. It can take your fingers off more easily. It can do a lot of damage really, really fast. In some cases, more easily than a bandsaw. Not as dangerous as a table saw, but it's bad. So do not play around. Like for this live broadcast, I will not cut shells on the router table live right now. I've done videos before where I set up the tripod, but in the course of a longer video where I have to go and do the setup and all that stuff all live, I'm just not going to do it for safety reasons. Richard Perry, I'll get to that. Hello, Shane Muse. Glad you made it. So the place you're going to make up time with trim molds is not necessarily in the actual trimming time on every single holster. You'll make up time by eliminating other steps that would come after. You'll eliminate cleanup sanding, usually. You'll eliminate adjustment and test fitting at the middle step to make sure all your lines are clean, your magazine button is clear. You'll eliminate a lot of that checking, because you'll know once you trim on the mold, it's to the numbers every time. You don't have to go back and verify it again. You can go right to your buffing wheel. I still think I've been getting good feedback. A lot of guys who have started trying those aluminum oxide flap wheels are really excited about them, which makes me happy. I think those are a great option for a rough finish right off the trim, right off the router trim. And then if you want to go hand rubbed or hand sanded or go to a higher grip polishing wheel like that, you easily can. But those do a really good job for me quickly taking out the tool marks that are left from the router bit, because the router bit does leave tool marks. It does not give you a glassy surface. You'll still have some texture there, a little bit of chatter, because you're hand holding the mold against the router bit. So you'll have some tool marks you have to take out. The flap wheels are great for that. Because there have already been a couple questions about what trim molds I offer. Here's the basic breakdown. I don't sell any trim molds by themselves. I'm involved in two sets of mold products. I make the HDPE molds that are sold by Pistol Forms. Conrad Miller designed them. I actually manufacture them, and then he sells them. Those are non-customizable, and we don't offer trims with those. It's just trims have to be customized, because every individual holster company has a different look, a different profile, a different cut, different sweat guard, different look by the muzzle. Like, there is no, and if we made a generic trim mold, nobody would use it, because nobody wants their stuff to look exactly like everybody else's. That gets complained about all the time. So of course, we're not going to make a generic cookie cutter trim mold. But in order to speed your process up, you're going to shave a little bit of time in a bunch of different places, and as much as you can, whenever possible, eliminate whole steps. And so for my molds, what I offer are those HDPE molds, which are completely non-customizable, and we don't make any trims with them. Some guys have taken them and cut them up and used them as the basis for trim molds, which you easily can do, and there are some real advantages to having the full profile of the gun in your trim mold, so the shell sits down and indexes front to back and rotational side to side. So you've got a sight channel and your Kydex drops in there, and the shell will be much more stable if you build it on an HDPE mold base. The trade-off is the backer on those HDPE mold bases, on those HDPE molds, is not very thick, which means you do not have a lot of router bearing surface to work with there, and you also don't have a thick enough material to put threaded inserts into. So if you were going to use one of those HDPE molds and cut it up and make it into a trim mold, you would probably want to screw it to an additional backer to give you some more thickness, so you could sink some threaded inserts in there and use machine screws to hold your part down. And it would also give you a wider margin of error by giving you a thicker edge to run your router bit bearing against. The other mold product I offer are full custom molds, which is where I do a complete design from the ground up, blocking for all the controls, trigger guard infill, open muzzle, closed muzzle, with threaded barrel or without, spacing between halves. Basically every feature of the mold is up for grabs. We go through multiple physical revisions where I send actual copies of the mold to the client for them to test in their shop. And then when they're done, I also produce a set of trim molds to their spec based on holsters they send me so I can see exactly how they like their cuts. I design a holster trim that reproduces that look and allows them to execute it consistently every time. Those mold packages cost close to $2,000 per gun model because I have an enormous amount of time in every single one. You're not really paying primarily for the physical mold. You're paying for all the iterations, all the revisions, all the design time, and the small tweaks and changes. You're going to change the ride height by an eighth of an inch. You're going to move this blocking a little bit, change the diameter on that. We're going to increase the trigger guard retention by 20 thou on one side, and then I make a new mold copy. What the user ends up with is a mold that's very carefully dialed in exactly to the spec that they want, but they end up paying for it because there's a lot of time wrapped up. So if you want trim molds from me, you have to buy a full mold package. I don't design trim molds based on anybody else's CAD work, and I don't design trim molds that will work with multi-molds or work with DIY drones or work with quick lock holster molds. In order to make the trim, I have to make the forming mold in CAD and then base the trim profile on all the geometry that's already built into the CAD model of the forming mold. So that's what guys are looking at when they buy custom molds from me. There's a lot of money wrapped up in it, but the end product is a very carefully executed, purpose-built solution for exactly what they want. And so those molds are designed to run with no tape, with no added blocking, with no adjustment at all, into the vacuum former time after time, completely consistently. Everything's machined in one solid piece. Nothing can shift, nothing pulls off, nothing breaks. They're just, you can just run hundreds and hundreds and hundreds and hundreds and hundreds and keep going and going and going. And so that's what my custom mold product is. Considerations for making your own trim molds. It's very important that you're able to hold the holster shell still. If it chatters and jerks around and bumps around, it's not as safe. And since a bunch of you have come in since the last time I said this, as usual, please post your company name in the comments if you're a holster company, and please share the feed while it's live. Please share the broadcast on your personal page and your company page so that I can get a chance to share this info with other holster makers that you know that I haven't talked to yet. Richard Perry, it's not exactly top 5 selling products for $10K. If you want to buy 5 molds, there are some discounts, but it is still spendy. But if you've got the volume of sales to justify that, if you actually need to make, say, in the next 4 months, I needed to make 900 Glock 17 with XC1, weird combo, or Glock 19. If I needed to make 900 Glock 19 with XC1 holsters because some government somewhere decided to outfit, all their Secret Service-ish guys with that combo, and somehow through a friend of a friend's uncle's brother, something or other, I got that contract, and I did make 900 of them, and I've got 3 months to do it, and they've got to be dead on consistent. The money coming in from that single order more than covers and justifies the tooling cost to tool up custom molds for that, and the speed and consistency with which you'll be able to execute that volume will more than justify it. At the end of the day, you will have a little less cash in your pocket when the order's done, but you will fulfill the order in dramatically less time with dramatically less stress. And so it's like, well, do I want to have an extra, $2,000 in my pocket, or do I want to fill the order 3 weeks early with a lower than 1% rejection rate of parts coming out of my shop? Which is worth more to me? An extra 3 weeks in the shop to make other stuff, or $2,000 by just, brute forcing my way through with a handmade mold with stuff that's taped on or glued on where stuff can shift or the mold breaks and then, I'm back to square one. It's just a question of, are you making something for which a high volume capable mold is a reasonable solution? If yes, get one. If no, don't. My molds are certainly not for everybody. For the customers who do use them, they're a great fit because those customers have come to me because they have enough volume of sales that they need to be able to go fast. And the mold system, once it's confirmed, once we've done the revisions and it's operational, that mold system allows them to go fast and go fast consistently. But yeah, I make no bones about the price. I'm expensive. But even at that price, I think I do my best to go above and beyond, and I think I offer a tremendous value for the money. So, pre-cutting, critical part of trim routing well. This is a single holster. I've got white lines drawn on it. I don't offer lines of credit, but your local mafia may. Hello, Nick Pratt. So these white lines show roughly where I would pre-cut this holster shell prior to putting it on a trim mold. Tony Kenner says that's cheap, actually, in my opinion. I know across the industry, when you get into tool, die, and mold makers, guys who can do injection mold tooling and other things, yes, $2,000 or slightly under $2,000 for a custom metal mold is, Daniel, I've had molds quoted by other companies when I was looking at getting them made for me years ago, and I offer a more thoroughly designed product at a lower price point. The reason I don't charge more than I do currently is because I don't feel that I yet command that price. It's just a question of what can I actually ask, what will the market say no to? But I'm a big fan of letting the market say no. This is something I learned from Gary Vaynerchuk. There's a little bit of Gary, sometimes a lot of Gary Vaynerchuk in every single one of these Facebook Live videos. But one of the things he said about pricing was, if you offer services, if you sell product, let the market say no. You'll find out what the market is willing to pay for what you offer. Cats fighting outside or something. If I was making a very plain, generic, inside the waistband taco holster with a foamy clip, and I was charging $135 for it, in most cases, the market would say no. I might find some people to say yes, but what about small tweaks to models you have? Tyler, there are no such things as small tweaks. We either customize molds or we don't. And if we don't, cool. If we customize them, there's design time and revisions and testing, and then there's money involved. It was a loud cat, or maybe it was like an opossum. I don't know what. I had a skunk outside the shop door a couple nights ago. Thankfully, I saw him before I stepped on him. He went scampering off, and I went scampering off. But let the market say no. I think it's better. So, Brett, Guncraft is a great example. He has a number of my molds. Not his entire product line is not being made on my molds, but many of his products are. And it allowed him to go a lot faster. And if you look at the lines on some of his newer ones, Brandon, it is a flat fee up front. You're paying for a package fee, and then the incentive is on me to deliver the final product to your spec in the fewest revisions possible to minimize my labor exposure. If I was charging for every revision, it would be easy for you to get underwater very quickly. I will not sell somebody an open-ended cost on a mold design. So the terms of my mold deals are somebody pays 100% of the mold fee up front, and I guarantee that they will receive a product they're very excited about, a satisfactory mold that does exactly what they want, or I will refund all of their money. And there's at least one person in this feed who I've actually done that for, who came, bought a mold, I sent them a sample mold, we went through one revision, they weren't happy, and I refunded all their money. Hello, Eric Olson. And so that's the way my guarantee works. You pony up all the cash up front, I work till the job is done, and you're completely happy with it, that's my guarantee. But Guncraft has done some really, really, really sharp work with the mold that I've made for him. I'm consistently impressed when I see stuff that Jeremy's made with molds that I've done for him. And yes, Gabe, the revisions are in HDPE. The master mold at the end is in aluminum. The trim molds, though, are always HDPE because that's a little safer on the router table. If you accidentally catch it, it's a lot safer for you to nick into a plastic mold than it is for you to have your router bite into a metal mold and send it flying. They're also just easier to handle. They're not as heavy. So the trim molds are HDPE. So yeah, every time I see a cool holster from Jeremy, I'm like, man, that's awesome. And I helped accomplish that. That's incredibly satisfying for me. What did you miss, Drew? Tib, a whole bunch of stuff. So back to the pre-cutting. In order to control the shell and have a good handle on the trim mold and not have it chattering or jumping around, there are a couple factors. I want to pre-cut as close as I can to my final trim line without having to go so slow that I'm actually losing time. So this is the balance of speed and accuracy. It's just like shooting. You can go blazing fast and get all C-zone or misses, or you can slow down a little bit and get A-zone hits over and over and over again. And then you want to go as fast as you can go and still maintain those A-zone hits. So when I'm pre-cutting these, when I'm trimming these, I will usually use my trim mold. I'll drop it on the inside of the shell. I'll lay the trim mold in here, and then using a silver Sharpie or some other very high contrast, this is white wax pencil, I will just quickly trace around the trim mold on the inside of the shell and then cut just on the outside of that line. It's very, very fast. I'm not beating myself up to try to be incredibly precise. It's just like zip, zip, zip on the bandsaw, just bulking the stuff off. What I'm trying to do is leave about 1/8 of an inch of plastic that will hang off the edge of the trim mold so the router has enough material to make a nice clean cut and leave a good edge, and I don't risk accidentally bandsawing inside my final profile. But the more material you leave for the router to take off, the heavier that router cut will be and the harder it will be to control the mold on the table. The more likely you will be if you're going along and your pre-cut was inconsistent, and in some cases you cut really tight, and in other cases you were 1/2 inch outside the trim mold. As you go around, the load on your router bit goes from very, very light to all of a sudden you turn a corner into a spot where you pre-cut badly, and all of a sudden the router is biting into tons of material. You're not ready for it. It catches the kydex, it bounces the mold, you miss the bearing, and on the way off the table, you cut your trim mold. Totally not fun. And I know it's not fun because I've done that. So the goal with pre-cutting is get as much material as you can get off consistently, quickly, close to the line, without accidentally cutting inside and ruining the part. If you find it's taking you 2 minutes to pre-cut a shell, you're going too slow, you're being too fussy. If you find that when you're routing, it's scary because the cut is too heavy, you need to pre-cut tighter to your final line. The other thing is, I'm a very big proponent of mechanically fastening the shells down to your trim mold. I know some guys just lay them on and hold them down with hand pressure. I don't like that because if you start to lose control for any reason or you take a hand away for any reason, the whole thing just disassembles itself. If the shell is not fastened to the mold, if the pressure from your hands is lightened for any reason, stuff can move. Not a fan of that. To get away from that, some guys are putting dowel pins in their mold and are pre-drilling for their eyelets and fitting the mold down over the dowel pins and then holding it down. That's better than just holding it on a modified HDPE mold where there's no through pins to stabilize it. But I still recommend, and what I do whenever I'm trimming shells by hand on the router table, which I don't do that often anymore because I've got CNCs, but sometimes I do. There are some variations where I've already got a trim mold and it's just easier to go over there if I'm doing 1 or 2 of them and it's not a high volume thing to just run it on there rather than stopping the mill and resetting it up and putting a fixture on there and cutting 2 of something. And so I still put threaded inserts. I use 832 or 1024 depending on the size of the thing I'm trimming, and put a minimum of 2 machine screws through my part into the trim mold so that it cannot chatter around on me, so that when I'm hand holding, if I have to shift my hands or lighten that pressure, I know that the screws are still maintaining a constant downward pressure on the shell. It's firmly seated on the mold. It's not going to pop off. Hello, Eric Powell. Yes, you're late. As a penalty, you must share the feed. Been a blast. Always got to sec later, bud. Alan, I did not respond to your email yet. It looks like Saturday evening should work for me, and I've already set aside some kydex for you. So hit me back up by email. I will try to respond. Remember to respond to the email tonight. But it looks like Saturday evening would work to have you swing by the shop and pick that stuff up. So safety first, always. Of course, eyes and ears with the router table. It's a high-speed spinning blade. It can do damage to your hands. Respect the tool. Don't be stupid. Fasten your shells down. And then I'm going to pick the camera up, and we're going to head over to my router table. I'm going to show you some things about how I actually feed in on the trim mold, and some tips about handling, a bit about feeding the work, about where to start the cut, where to end the cut. Some real nuts and bolts, practical stuff based on how I like to run trim molds. Oh, before I do that, though, one or two other ways I've seen guys stabilize shells. I know a few companies. I think Todd May is doing this. I think Ryan Brack may be doing this. Or Ryan, yeah, Triton Holsters. Using, Nathan Gallup, we're on Eastern Standard Time. Like it said in the photo and like it said in the text of my post, 9 p.m. EST, and in the photo, Facebook Live, 9 p.m. EST, which in Nathan Gallup speak is some other time, apparently. So you're late, too. You have to share the feed. But please do share the feed if you just joined. You were working. Yeah, well, happens. It happens sometimes. I think you were probably just sitting around making rude jokes with Angelina Beebe. There is only one time zone. All others must comply. You must mean Greenwich Mean Time, right? Pacific Standard Time for the wind. Hippie California commie loser. What is this garbage? Or are you in Portland drinking your soy latte? Probably decaf. After all, it's barely even the evening where you are. So some guys are using flat material, 1/2-inch plywood, 3/4-inch ply, MDF, a sheet of HDPE. Yeah, burned. Using some kind of flat material and putting your profile in it and then laying your 3D contoured shell on top of it. That can get a little bit dicey. You need to support the shell. And the quick and easy solution that those guys have done that I've seen that seems like it would work well, although it's not as good as a fully supported 3D shape that matches the shell, would be to drill holes in your board, have two that index your shell so it aligns based on eyelet hole location, and then take dowels and push them through from the bottom until they hit the underside of the shell when it's in its neutral position resting on top of the mold, and then wick some glue in from the underside so those dowels are locked in place, and then trim them off at the bottom so the bottom of the mold is still flush and you can slide it around on the table. What you've basically built in are custom support posts for critical spots in the mold so you can apply downward pressure without deforming the shell, because if there's no support under it and you push down to hold it down, you're just actually going to compress it and you're going to spread it off the edges of the mold, and then when you trim and then let go, it's going to retract and your actual cut will be inside the perimeter of your trim, which defeats the whole purpose. Don't do that. So you can do it with plastic blocks. You can do it with dowel rods. You could do it. You could even do it if you needed to. You could, put a screw in, lay the shell on, see if it touches, back the screw out. You could, there's a bunch of ways to do it, but you need to find some way to support the shell, especially at the highest points, end of the sweat guard, places where the shell is most flexible and most likely to chatter when being cut. You want to support it there, and then make sure, especially at those chattery spots, the sweat guard is a big one, that you trim as close to your final profile as possible, because the heavier cut you take with the router, the more likely you are to have the kydex flexing and flapping and chattering, and then you'll have more tool marks that you'll have to get out. Your opinion on the homemade epoxy trim boards. Cody, I've never tried them. I think they could probably be executed well or executed poorly. I wouldn't trust clay, Tyler Miller. The reason I really like the plastic HDPE is because it's basically impervious to the bearing. It doesn't rub or wear out. I have used in a furniture shop, because I did custom high-end furniture for a couple of years. You know, we did router trimming, exactly this kind of thing, where you'd lay parts on a template, index them with pins, clamp them down, and then trim them to shape. We did tons of that using MDF templates. And we did definitely find that over time, the bearing will groove into the side of the MDF. One way to deal with that is to strengthen your edge by impregnating it with CA glue. You basically soak super glue into the edge to harden the MDF to make it more wear resistant. In place of the dowels, Tyler, I don't know, clay might work in place of the dowels. That'd be an option. You could probably put some on there and smush your shell down, as long as you actually harden that clay. I wouldn't trust soft clay necessarily to be stable enough to use. So I'm going to pop my mic off. I'm going to turn on those lights back there, pick up the camera, and take you guys over to my router table and talk about actually cutting the shells. So let's do that. All right. If you want a budget-friendly trim mold, trimming another HDPE mold would work the best, I think. My only comment on that, Dan, was what I said before, and I actually, no, I do have one of the HDPE molds handy. I'll show you what I mean. This one, you can see how thin that backer edge is. This is that 1911 mold I used last week in the broadcast for the thrift press. There's not a lot of material there to give you a good bearing surface to run your router bit against. So if I was going to use one of the HDPE molds as a trim mold base, what I would probably do would be screw it down to a piece of 1/2-inch thick plywood and then use the plywood and the HDPE as the base. Or just give me something so I've got room, I've got a larger surface there to work with. On my trim molds, the spec is that I leave the backer plate 1/2 inch thick, because the threaded inserts are like 0.45 or 0.465 tall, and that leaves me enough room to sink the entire insert in, not have it stick out the bottom, and get full thread engagement without making the mold any taller than it needs to be. So here we are at my router table. Let me drop this down a little bit so you can see a little better. All right. So, few points right off the bat. This is the Amana bit that I use most often for trimming. This is a 1/2 inch diameter by 1 inch length of cut with a 1/4 inch shank. I've got it in a Porter Cable 892 router. When I adjust my bearing height, and as you can see here, I've got my router locked out. I verify by switching the router on, it does not turn on. I never handle the bit. I never take the router out or make any adjustments with the router plugged in. Don't be stupid. You could fumble the switch and turn that puppy on while it's out of the table and you're handling it and be in huge trouble. So, anytime you're doing maintenance or service on a machine, bandsaw, drill press, anything. Like if you've got the top of your drill press open to change the speeds by resetting the belt from wheel to wheel, unplug that sucker. You have 10 fingers, keep all 10 of them. I always adjust the bearing so that the entire bearing rides just above the table. I do not want any part of the bearing buried below the table. I want to make sure I get as much contact as I can. The only time I would ride the bearing any higher than the table is if the total height of my trimmed part required me to get the very top of this cutter a little higher off the table. What I mean is, because I'm always when I'm dealing with height, I'm dealing with the sum of the 1/2 inch thick backer plus the actual molded height of the part. So the example is light bearing holsters. A 1 inch length of cut bit is not tall enough usually to cut all the way through the top of the light channel. The light channel is usually wider than the gun if you're dealing with TLR1, TLR2, X300 Ultra. And so you need to go to an 1.25 or 1.5 bit. 1.25 barely makes it. 1.5 is a very safe margin. It gives you plenty of cutting edge. But I don't like using 1.5 generally for my standard non-light bearing stuff, just because if I can avoid having an extra sharp bit sticking up here spinning at 16,000 RPM while my fingers are close, I'll do that. I want as little exposed blade as possible near my hands. So I use the 1-inch nearly all the time. I set it up so the bearing is fully above the table. Let me pull this down here. Around and show you. The bearing is fully above the table. And then I would always go around and verify. Man, it's just not focusing. Verify that the bit will fully clear the highest parts of my part all the way around. I do this dry. Anytime I'm setting up a new trimmer, I'm changing molds, I will always verify. And this table is just sheet metal. It's not actually that flat, so parts kind of rock around. I always stand in the same spot and feed, so I've got more consistent contact. So setup here is key. I always want to double check my bit height, make sure I've got full bearing engagement, make sure the top of my cutter will actually cut through the highest part of the shell, run that dry with the machine unplugged, just feeding around and eyeballing it to make sure it's going to work, and only then will I actually get around to cutting the part. Looks like my comments froze up. If a couple of you could leave a quick comment right now just so I can see if those are coming through, that would be helpful to me. Now, when it comes to actually feeding in a holster shell, let me turn on one more light here, 1 second. All kinds of junk just sitting around over here. Oh yeah, that'll be better. That'll be much better. Should have thought of that before the broadcast. Oh yeah, tons of light. Maybe too much light. I always feed in. Still here, senor, says Brandon. A man walks into the bar. 1, 2, comments. Ta-da. I always feed in at the flat end of my muzzle. And when I'm feeding in, I don't feed in when I've got a trim shell on here. Yeah, I need an upgrade. I mean, I've got my upgrade right here. This is a giant Delta Shaper that just puts my router table to ridiculous shame with this beautiful steel table. I just don't have it wired in yet, and it needs some TLC and some derusting and some lubrication and setup. But that thing is the beast that's going to do awesome trim work for a long, long, long time for me. But yeah, this thing totally smokes this little built from kit table that I've got. But this is made tons and tons of fine parts. So when I'm feeding in, let me change the angle so the lighting's a little bit better. Yeah, here we go. This is how I don't feed in. If I've got a holster shell hanging off the end here, I don't do this. Boink. And run straight in to the shell. Okay? I will always feed in using 2 hands, okay, which is not shown because I'm holding the phone. I will feed in at an angle so that the bit gradually bites into the work, but the goal is to get the bearing in contact with the trim mold. Because if I'm out here and I'm floating off the edge and the cutting edge is in contact with the holster shell and it's cutting and it's exerting force, it's rotating this way, it wants to grab the mold and throw it that way. If I'm just free holding it in space and I'm not against the bit, it's much harder to keep it stable. So this is a nice, tall, thick, flat edge, and I know where that is. When I'm pre-cutting my shell, it's very easy to cut close to that line. That's very easy to lay the shell on the bandsaw and zip 1/8 of an inch beyond the muzzle there and have a very clean, consistent lead-in margin. Feed in right there, and then I work my way around, all the way around the rest of the holster shell and finish out back at that bottom muzzle. Okay? Right here in this corner is where you'll typically see a heavier load because it's pretty common that your pre-cut will go shallow in this corner. You'll take a larger radius. You'll come straight across here, but you won't be able to keep 1/8 of an inch margin tight through that turn. You'll usually go wide. So you'll have more material hanging off there. Wherever your pre-cut tends to be heavy, learn where that is and anticipate it. Make sure you have solid two-handed support on the mold, and then try to feed in and feed out of that heavy part in one clean move. I change hands often when I'm trimming. I'm going to put this back on the tripod and simulate one go round. If I were actually running this with a shell, here's how it would look. I'm going to feed in at the muzzle here. I've always got two hands on the mold. I'm not going to put a shell on here just so you guys can see the mold clearly and see the outline and how it contacts the bit. I'm going to feed in here at an angle, make contact with the bit, and then keeping pressure, not heavy pressure, but consistent, firm pressure against the bearing. I'm going to feed around here, and you can always stop, get off the bit, and then pick up without any contact catch, because the shell that overhung here, the spot you've already trimmed, it's gone. You can go straight to that edge, and the bit cuts nothing. It won't catch and throw. So if you ever need to reset, you can always pull off, back up 3/4 of an inch, feed in, and then continue. What I don't like to do, first of all, I don't want to have fingers around the corner. If I suddenly turn, I don't want fingers ever hanging off the edge of the mold. Fingers are always inside the edge of the mold. And I want to try to make sure that I don't have a situation where I'm shifting both hands at the same time, because then I don't have good, consistent downward pressure on the mold or pressure against the bit. I'll try to shift one hand at a time. If I need to reset, pull away, change the orientation of the mold, feed in again, and then continue, I'll do that. There's no problem. Do whatever is comfortable and safe for you. Don't put your fingers at risk, and don't make bad parts. So I'd feed in here, I work around the edge. I'll usually, before I turn this corner, I'll stop, I'll reset, I'll pick up here on the flat, turn that corner. This is a heavy cut. I'll come all the way through here, and I'll pull. Rather than trying to rotate the mold and feed this way, because if I drop off that edge, I could feed my hand into the bit. I'll always come through here, and then pull, and cut that end, and then cut out, reset, start here, wrap that corner. This cut's usually a little heavy here in this angle by the magazine release. I'll come down through, finish that cut out to the corner, and then finish the cut around, and then right here I break into pre-cut area. The resistance goes away, I know it's done. That's how I do it. There's usually at least one pull off and reorient. And then when I'm going around the sweat guard, I'm keeping the orientation of the mold consistent and pulling through that finish. You can also just pull all the way out there, okay? But I find that that corner is probably one of the most chattery parts, and I want to keep that constant contact and slowly, with good control of the mold, feed around that corner. Hopefully that makes sense. Let me see if there are any other comments. No other comments. Apparently, they made perfect sense to everybody. Everybody got it, and there were no questions. While I'm here, if you have questions, please don't hesitate to ask questions, because I'm happy to answer questions about how I do this, or particular ideas or thoughts you had about how you do it, improvements you might suggest. If I were doing a light bearing mold, basically everything is the same. Not much changes. This is for an older trim mold for my X300 Ultra Appendix. It's gone through some revisions, so this mold is no longer in production. This trim mold is no longer in production. You can see my threaded inserts right here and here. I try to locate them kind of centrally on the mold. I wouldn't want to do these bottom corners so far from there. I want them, if I've got multiple options, I'll go with whichever ones are more central. So I would pre-drill those two holes on my shell, lay the shell on, put these 832 screws in, bolt it down. Same thing, I'm going to feed in at the muzzle on this nice, thick, flat edge at an angle so I hit the work gradually and then get into the bit. This is a larger mold. It gives me more real estate to work with. I'll come around here. Normally right around here, I'll pull off, set this hand, come around this corner over to here. Anytime you have an RMR cut on a trim mold, that's definitely going to be a heavy cut because you're never going to cleanly pre-cut those corners. You're always going to leave them heavy. So I'll come in here. I want a lot of support. Sometimes I'll even drag the edges of my hand on the table so I'm not only skating on top of this. If this gets thrown, if I'm locked on the table, I can support it and prevent that from happening. If my hands are just on top of the part, if it moves, the only way that I can keep it from moving is applying enough downward force that friction keeps it from shifting. Here, my hands are locked down. So coming through those RMR cuts, I'll often drop my hands onto the table. I'll come through here, and then as before, I will pull out around the corner of the sweat guard. And then reset, get my fingers away from these edges. Start up here, cut around that corner, down past the magazine release, down past the trigger guard, around the retention screws, back up to the muzzle, and done. How much is CNC, says? Your process, even the pull's about the same as mine, says Tom Kelly. It's all about control. You got to keep your fingers. How much is CNC? Joey Gregory. This small CNC, which is a 2x2 foot machine, ran me, in 2014, ran me almost $8,000 worth of computer, not including tooling, not including dust collection, not including CAD/CAM software, just including software to actually run the machine. And so I would say you're looking at, if you want a small desktop machine that uses like a Dremel-sized tool to do the cutting, you're in $1,000 or so. If you want an actual router with some more serious torque and some more RPM that can take heavier cuts, then you're in at least a couple thousand, and there's a huge learning curve. So unless you've got a lot of free time and thousands of dollars laying around, I would say CNC is not for everybody. Some guys are just interested in it and they want to learn it anyway, and so for them it's work and pleasure at the same time. It was that for me, and I have other things outside of holsters that I do with CNC that I really enjoy, so it's totally been worth it for me. But CNC is by no means a shortcut to turning your holster operation into a money machine. Let's see, what else? That's how I run the trim mold. As much as possible, if I could leave this router table set up like this with the bit and everything set at the height I like and never mess around with it, that would be ideal. From a consistency standpoint, I'd be least likely to have problems and mess things up. Hello, John Baker. Did you stop by and try that amplifier yet? My mind was totally blown when I plugged it in with my pedal board. It was awesome. Okay, Matthew Bills. That's a bad idea. Don't get a 4x8 foot kit CNC. Oh my goodness. That sounds like a nightmare. And the reason it sounds like a nightmare is the bigger the CNC is, the more important it is that it's rigid and it's stable. You had to tear it down. Why'd you have to tear it down? I'm planning on playing that amp on Sunday, so better not be too torn down. All right, I'm back on the mic. Building your own CNC from a kit can be fun if you have time. I had no interest in building from a kit, and I knew that if I was building from a kit, that there would be gremlins, and that I would drive myself absolutely bananas trying to find them. The common ones that guys are getting into right now are the X-Carve, the Shapeoko. Some guys are using the Shark or Shark Pro. Those are all, they're hobby-level machines. Probotics machines are the same way. In a lot of cases, the companies that make those provide virtually no support. The support network is the forums and user groups of other users, most of whom are also hobbyists. It's not that you can't make good parts on those machines. It's just you won't do it quickly, and there will always be some things. Hobby machines tend to not adopt industry best practices just for budgetary reasons. Industry best practices for CNC are expensive because they're durable, they're stable, they're sturdy. And if you're trying to build a desktop CNC for under $1,000, you can't afford to put $5,000 worth of ball screws in it. You just can't. The end result is oftentimes those little machines, learning how to use one is kind of quirky, and how you learn to use it and the shortcuts and workarounds that you end up using to get it to do what you want won't translate onto any other machine. Okay? The goal for me for CNC is get it developed so that it runs the same way consistently every time, day or night, hot or cold, whether I'm in a good mood or a bad mood. So I don't have to like do a little rain dance and say some incantations and flip the on and off switch 9 times, with the last one being a little slower, in order to get the machine to reset the way that it wants to, so it makes my part the way that I spec'd it out. If the process is not consistent, and at the end you're constantly having to check your CNC parts to make sure they're within tolerance, then the CNC process is not saving you the time it could. Holsters are not high precision work. We're trimming really, really thin sheet plastic. The machine barely knows it's cutting anything. The stuff has so little resistance. It's so easy to cut. If you're doing aerospace parts, you're making space engine components, yeah, you'll verify every part. The dimensions and the precision and the temperature of the room that the machine was in when you made the part matters. For holsters, not at all. And especially when, even after CNC cutting, you're still taking it to a buffer and some person is manually grinding on that edge. That changes the profile a little bit. Not major, but we're just not dealing with precision parts. Matthew Bill says the gantry flexes horribly on the Shark. They over-torqued the screws and the HDPE guide rails cracked and it cut horribly after that. Yeah, I would be reluctant to get a Shark. I don't think that a $1,000 machine that doesn't work well is a bad investment just because it doesn't even get you $1,000 worth of stuff, of work done. There's a saying in the CNC community, which I think is very good. It's buy your second machine first. It doesn't mean buy 2 machines at once. It means look at what you would want your second machine to be able to do. And then skip the JV step. Skip T-ball. Get the real deal machine first. If that means waiting 6 months longer and saving more money, if that means, when I bought that CNC, I sold guns. I didn't have cash on hand to finish paying for that. I knew I wanted it. I knew when I wanted it. I had upcoming projects I needed to use it for. I needed to pay for it. Didn't have a lot of other cash available. Didn't have a lot of assets that I could just turn around and sell. Sold guns. Sold some of my personal guns off to cut the check to get that CNC in here on time. Have I regretted it? No. I've replaced those guns. I've bought them back since 2014. That's not been a problem. But if you're looking at spending $1,000 and getting a really hobbyist machine versus spending $4,000 and getting a used machine that's actually got some chops, there's cost and there's value. And I've talked about this with tools before. The lowest cost is often not the best value. This is why I don't buy power tools from Harbor Freight. In my experience, power tools from Harbor Freight have been low cost and a poor value because they break. It doesn't matter if I save $50 if the thing doesn't work well. If it causes me headache, not worth the savings. So I looked at Probotics and I looked at Shark and I looked at a bunch of those other hobby consumer CNCs when I was shopping for this one, and I'm really glad that I bought that machine, the one that I have, that small router, rather than a cheaper one, because I would not have been able to learn as quickly, progress as quickly, push myself if I had a less capable machine. And then I upgraded to that bad boy, and I feel like I'm driving to and from the grocery store in a Ferrari. I have barely begun to tap the slightest part of the potential of what that machine can produce. Running that thing is awesome. It has its little quirks, but they're not machine defect quirks. They're just getting used to the user interface because it's not, the button labels and sometimes menu organization is not always intuitive. But that's life. You know, the machine's got tons of power. It's got tons of speed. If you guys saw my video on Instagram today of drilling TDI sheaths, to counter Andrew's comments on how much to spend. I'm not sure that's really a counter, Tom. I think what you just said and what I've said are completely in line. For a lot of guys, you can get a much better mold made quickly by paying somebody who's got over $100,000 in machinery to make it for you versus trying to do it yourself on your own budget equipment. Except the 2 horsepower dust collector at Harbor Freight's been running for 4 years now. I mean, Matthew, that's the guy who's got a Taurus 1911 that never jams. I'm sorry, that's what it is. Anecdotal evidence that some Harbor Freight power tools last a long time in no way negates my point that generally power tools from Harbor Freight are cheaply made and are a poor value. Everybody knows it. Everybody knows it. Harbor Freight tools are not well made. If I need to buy a hammer, a sledgehammer from Harbor Freight, I have no problem doing that. Okay? But, you know, this is exactly the conversation we have with guys when they ask, what kind of gun should I get? And when you hear somebody suggest Keltec or Taurus or or High Point, you're like, man, High Point's not really. And the guy's like, well, I put thousands of rounds through mine and it never jams. Okay, you got the unicorn. Good for you. But for the majority of users, that's not their experience. Like, I know lots of guys who have shot Tauruses and said, this is a piece of crap, it doesn't feed well. Okay? The consensus, individual counterexamples don't negate an industry-wide consensus about the dependability of certain things. So I don't have any interest in buying a $1,000 CNC. I don't trust it. I know what I expect my parts to do. I know how fast I want to have them made, and I do not have time to be going back and checking them and babysitting that machine to make sure it's not screwing up every once in a while. I'm going to turn some lights off overhead. Still too bright in here. Mood lighting. And now we shall discuss value. Yeah, I mean, maybe the dust collectors are like a diamond in the rough, the one good thing that's there. I go to Harbor Freight for things like spring clamps, hammers. I was at Harbor Freight a couple weeks ago, and I walked around for like 45 minutes trying to find something I could buy. I ended up buying some microfiber rags and some rubber gloves, and that was it. I looked at a bunch of tools. I'm like, no, not buying that. I don't trust it. I don't trust their air. I don't trust their air fittings. I don't trust their hoses. I don't trust their lights. I don't trust basically anything from Harbor Freight. And I know that there are guys who love Harbor Freight and buy tons of stuff from there. But I also know guys who love $5 lockback pocket knives and buy 10 of them every time they go to a gun show. And every single one of them is garbage. They don't hold an edge. They don't lock back well. They're flimsy. They're unsafe. They look like crap. They feel like crap. They cut like crap. They're crap. Yeah, so, their lower end ones, their smaller ones are definitely junk. They make vacuum pumps, If I'm looking at spending $100 on a vacuum pump that I don't trust versus $275 on a more powerful vacuum pump that I do trust, there's no question for me where the value is. Skylar, I do have Harbor Freight calipers. I use them to measure the size of rocks that I throw at my neighbor's house. That's about it. And so I always want to buy, whenever I'm shopping for my business, I'm always looking for value, always value over cost. HDPE, says Alan Morrison. What about it, Alan Morrison? I like HDPE. I use a lot of it. Depends what you want to do with it. Bwahaha, says Skylar. Yeah, sometimes. I just need to know, is this... And I mean, the Harbor Freight is like plus or minus a half inch. I'm like, oh, this is a 3-inch rock. That'll make a good thunk. Off it goes. Haven't gotten any windows yet. Someday. And so I'm always shopping for value. So last night I spent $1,000, more than $1,000, on something I wanted to try out for my business to see if it's going to work for me. Where can you get the HDPE molds that I make? Alan, you can get them at pistolforms.com. They are in stock, ready to ship. Conrad Miller from Strongside Concealment runs that site. He has those molds in inventory and can ship to you promptly. We've got 15 models released. My neighbor's a good friend of mine, Brandon. I don't throw rocks at his house. C&CS, the killer potato gun. If you want to build a potato gun, go to Home Depot, buy PVC, build a fun one. I got nothing to do with it. I don't have any interest in potato guns. So I'm shopping for value. So I spent $1,000 on something that I want to try out for my business to see if it will do what I want. And if it doesn't, I'll probably resell it, take a small loss on it. But even if I lost $200 or $300 on it, that $200 or $300 is a very reasonable investment for me to spend to get the thing in my hands, to taste it in my shop, to see how it works, and figure out if it's going to be a good fit for me, if it's going to be a good idea. So, end of December, tax season's coming up. I'm looking at my business expenses list. I'm looking at my cash on hand. And it's always at the end of the year, what things do I want for the business that I have cash to buy now? Let's just get them bought and expense them. And so I went on a spending spree last week and this week. Bought a whole bunch of stuff. Power transformer for the shop, parts and fittings and accessories from other companies that I want to check out to see how they work. All kinds of cool stuff. What is this mysterious item? Well, it will kind of affect how much I get into slide milling, pistol mods, that kind of machining work in 2017. I'm buying optics. I'm just buying up optics, trying them out. A couple different optics. Because Trijicon RMRs are not the only thing guys mount on their guns, but Trijicon RMRs are the industry standard. So I bought a couple of those, bought some barrels, bought some other stuff. I'm just trying things out. Because I need to see what it's like. Can't know without trying it. Any other questions you guys had about trim molds? I feel like I've kind of used up the material I prepped. There's not a whole lot else to say. Trim molds are an effective way to speed up certain parts of your process. They can improve your consistency. They can improve the quality of your profile. They can make the parts look awesome. Some of my favorite photos. I've really been enjoying seeing the pictures that Triton Holsters puts up of stacks of different colored trimmed shells because he's got his trim molds dialed down. Oh, that reminded me. He explained in a discussion on one of the Facebook groups how he went about locating his drill indicator pins on his forming mold. And it's the way I used to do it manually too, which is you make a very, very slow, careful, exact master copy of the holster. Then you lay it back on your mold and you retransfer the drill locations from the holster shell back into the mold and then put little steel pins in those spots so that you have dimples on the inside of the holster shell every time you form. DIY trim mold tutorial. I'm not gonna build one. I don't have any interest in manually building a trim mold. It's not really a good use of my time. There are other guys who are doing it, and they should shoot Facebook Live videos about it. I know Skylar Gibbler has done some Facebook Live videos about making trim molds. I can explain to you how I would do it. I would take an HDPE mold that matches the model I'm working with, if an HDPE mold is available for that model. I would drill a few holes through the body of the gun. I would screw it down to a piece of 1/2-inch plywood. I might also put some glue in there so that I thicken up the base that's underneath the gun. And then I would go ahead and make a master copy of my holster shell. I would not bother unfolding it. I'd make a shell, I would have it folded up, I'd have it fully trimmed, sanded, finished out, everything, but I would not put eyelets through it. Then I would just take a bandsaw and I would just cut the sight channel line out so the two halves are independent, drop them on there, mark my lines, okay, and then very, very carefully bandsaw and then sand to those lines, and then I'd have a trim mold. That'd be it. But if you only get the consistency doing it manually by going slow enough to be very careful. You have to make your initial master holster very clean. If it's not clean, you're going to transfer those errors back. Get it all the way right. Take however much time, if it takes you an hour to make that one holster, an hour and a half to make that one holster, so it's completely clean, do it that way. It's the thing that's going to control the accuracy and the consistency of everything downstream that flows from it. Get it all the way right. Buy my molds from. You can buy the HDPE stock molds, which are non-customizable, from pistolforms.com. If you're interested in the couple $1,000s a pop custom mold packages, send me an email, orders@henryholsters.com for custom stuff. They're not listed on my website. Since everyone is custom, there's no point in having them in menus. Everyone is quoted on a per project basis. But the HDPE ones are at pistolforms.com and they're in stock. So when you're using manual processes to make a master template, go slow, get it right. Double check, triple check, measure carefully, sand gently, and then make your trim and test it, and then you can always make adjustments. You can always make adjustments to a manual. You can always take material off. You can't put material on. And so if you use an HDPE mold screwed to a plywood base, if you ever needed to make an adjustment, you could pull the plywood, screw the HDPE down to a new sheet of oversized plywood, bandsaw slightly large of your HDPE, and then use a top bearing bit to guide on the HDPE and cut the plywood flush to the HDPE, and then just skip whatever spot you need to adjust and sand the plywood into shape at that point. So you could sort of reset the mold if you went too far in one spot, but generally go slowly, trim a shell, fold it up on a gun, make sure everything looks right. And then if you're thinking about taking more material off the trim mold, do it judiciously and slowly. And what Michael Hallam just said, which is take some of the HDPE molds and make them into trim jigs and then invest in aluminum later, that's a very reasonable way to go about this. If I was starting trim jigs manually myself in my shop, I would be doing just my top two models, because there's going to be enough little changes to my process as I incorporate and get comfortable with making trim molds that if I make two, it's not unlikely that after a month or two of using them, I would throw them away and remake them. What I don't want to do is make 10 of them, then learn some important lesson after a month, throw away 10, and remake 10. Always get a taste. Make one, make two, maybe make one for non-light bearing and make one for light bearing, and use them both. Maybe make your G19 with XC1 trim and your M&P Shield trim, and use them both, and learn as much as you can about the process. Get comfortable with the workflow. Get good with your router table. Make sure you can set it up safely. You can cut good trims, that you are comfortable, that you're getting clean enough edges that when you go to your buffing, you're getting the tool marks out quickly and consistently. Get the whole thing dialed in. Hello, Jason Craig, because you're late, share the feed. I'd appreciate it if you'd share it anyway, but if you're late, you have to share the feed. It's kind of the... I won't call it penance because I'm not Roman Catholic. But, share the feed, Jason. So get a taste for the process. Don't try to jump with both feet all the way. Like, if you're thinking about getting into this pool, put your foot in. See how it feels. You will learn more, always. You will learn more by doing than by reading, than by watching, or by talking. And this is why there's this tension about don't spoon feed the new guys. Okay? On the Codex Forum groups, on the Facebook groups, and on CodexPro.com, there's always this tension about don't spoon feed the new guys. This is my fundamental objection to spoon feeding. Spoon feeding, real spoon feeding, handicaps by short-circuiting learning. There are certain things that a guy will not learn, cannot learn, does not learn until he does it himself. He makes the mistakes in his own shop. He pays for the plastic. He pays with his time, and he might pay with a little bit of blood. Until he does that, the lesson doesn't get all the way in there. And so if we just explain ahead of time, some of those valuable lessons don't sink all the way in, which will sometimes create weird problems down the road because we got it and we don't have that problem in step 5 because we learned a certain lesson in step 2. A guy who short-circuited step 2 didn't learn that lesson, doesn't understand why step 5 is the way it is, keeps messing it up, can't figure out why, gets frustrated, and he just like I'm a big fan of learning by doing. But I read, I watch, I talk, I want to learn every way I can, but there is no substitute for doing. And anytime somebody comes and asks for info about something that they have not even started to try to do, that's where I think we start getting into spoon-feeding territory. Okay? If somebody says, I'm thinking about doing this, I've never tried it before, how do all you guys do it? I don't like that. It's not necessarily spoon-feeding to help him, to point him in the right direction, and there's tons of information already. Google is your friend. Chip, I taught everything from 1st grade through 12th grade. I taught grammar, Latin, science, writing, math, biology, history, literature, poetry. I taught a whole bunch of things. I think my sweet spot was elementary grades 3 to 5 or high school. I wasn't an especially good fit for a middle school classroom. Did it, but it wasn't where I felt most comfortable. So I want people to learn. I'll do my Alex Jones impersonation. I don't know. Live, which one? Well, Aaron Jones, you're obviously here. I don't teach shop. It's crazy. I used to occasionally have students out to my shop and I'd show them stuff, but I didn't have a shop at the school. But yeah, now I teach grown-ups shop class. Hey guys, welcome to shop class. But in your own shop, in your own process with trim molds, there is no substitute for doing. Talking is fine, but do. Listening is fine, do. Watching videos is great, do. And once you do, you will learn lessons that I can't teach you in a Facebook live feed. I can't show you on video. You can't read on a forum. You can't read in manufacturer's specs. You can't find out in an answer from a text message from a friend who's also a holster maker. You have to do it. You have to taste it. So if you're thinking about getting into trim molds, make one. If I was going to make one right now and I was on a super tight budget, I would take an HDPE mold and I would use plywood as my trim base. I would use the pin option from the bottom to set the heights to stabilize my shell. I would try that. That's what I would do. You'll need to have some way to locate the shell, so you'll need some indicators, at least one per side, that are tightly fit to drilled holes that you pre-drilled through the shell so the shell locks into place, and you have to locate those pin locations extremely carefully. So you've got to have a good center line drawn on your trim mold to base all your stuff off of. You got to lay out those two lines to locate those indicator pins very, very, very carefully. Then make a trim mold and try it out, and you'll probably scratch some shells. And by probably, I mean you will certainly, definitely, unavoidably scrap some holster shells. You'll throw away plastic, you'll throw away time, you'll scratch your head a little bit, and you'll learn. That's the whole point. We do to learn to do better. Practice doesn't make perfect, says Michael Martin. Aaron Jones, I'm glad to see you here. With the holidays and being in and out of town, it feels like I haven't seen you in a while. So I hope I'll see you this week. So that's pretty much the end of the broadcast on trim molds. I got a bunch of TDI sheaths still to run, so I'm going to warm up the brother and get back to that. Thank you guys for spending your time with me. I appreciate you sharing the broadcast and leaving me comments. As I usually do, I will go through later tonight and read through all the comments on the entire video, every single one. I always do. And I usually like most of the comments, almost all of them. And if there are any questions that I see in text in the comments that I did not get a chance to answer in live during the video, I will do my best to answer them in text. So if you asked a question and didn't get an answer, check back later and I will get to it. So thank you very much, guys, for your time. Today is Thursday. This is probably going to be my last live video for 2016, unless I get totally crazy and get in here on Saturday night and decide to just go for it. Thank you, Jess Haslar. Appreciate you watching. So if I don't talk to you before then, have a fantastic new year. I am super excited for 2017. I got all kinds of plans. I'm getting my first employee. All kinds of cool stuff is happening in 2017. I'm going to be launching some new products. I'm probably going to be launching at least one new brand. I'm bringing in some new equipment. It's just like letting off the brake pedal, stomping on the gas pedal in 2017. So take care, guys. Have a great night. See you later.